In this section, we're going to examine what it is to be the slope of a line and actually how to calculate the slope of the line. Let's look at our first example. Here we're going to find the slope of the line that passes through the following 2 points, 6, 1 and -4, 1. So what we're going to do here is if you were to plot these 2 points on the coordinate axis, connect them and draw the line, we're going to find the slope of that line that contains these 2 points. What we have to begin with is called the slope formula. And you should have reviewed this already. Let's write it down. The slope m, and remember m is always the variable reserved for our slope, is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now you might be asking yourself, what is this lowered 2 and 1? What does that mean? When we say the word y sub 2, it's really a shortened for y subscript 2, y subscript 1. So what we're going to do then is, this is our slope formula. We're going to look at our 2 points and decide which ordered pair is x sub 1, y sub 1, and which one is x sub 2, y sub 2. Well, the great part about using this formula is it doesn't matter which one is x1, y1, and which one is x2, y2. You get to decide. So since this one here is to the left, we'll just call this first ordered pair x1, y1, and we'll call our second ordered pair x2, y2. Now that we have that done, all we then do is take the numbers and substitute it into our equation, and we'll be able to calculate the slope. So this is equal to y2, which is over here, is -1, minus, notice that's part of the formula, so be very careful here, minus y1, which is 1, over x2, which in this case is -4, over x1, which in this case is 6. Now, basically then, we're going to do this quick arithmetic. -1 minus 1 is -2, over -4 minus 6, -10. This reduces -2 over -10 simply to 1/5. So what does that tell me? That tells me the slope of the line that connects these two or passes through those 2 points happens to be 1/5. That's the slope of our line. Now that we've done that and we're familiar with our formula, let's change the points and try again and see what happens. So this time, we're going to change these points. Let's keep our slope formula for reference. And let's go ahead and recalculate and see if there are any special cases we have to be aware of. So this time we're going to find the slope of the line that goes through the following 2 points, -5, 6 and -5, 3. Now again, it doesn't matter which ordered pair is x1, y1. You can choose. Just to show you that it doesn't matter, I'm going to make my first ordered pair this time x2, y2. So this is x2, y2 this time. Again, why? Because I chose it that way. You can make your own choice. This one here is going to be my x1, y1. Now let's see what happens in this problem. y2 is equal to here 6 minus, because that's part of the formula, remember, y1 here is 3 over x2, -5, minus, part of the formula there, x1, which is also -5. Let's do our calculation here. 6 minus 3 is 3. And what happens in our denominator? Well, we get -5 minus a -5, which we know is the same thing as plus a +5. -5 plus +5. Uh-oh. We've got 0. Now, what does that mean to have a fraction with a 0 as a denominator? Remember, that means this is undefined. Now, what does it mean to be undefined? Well, if you ever get a fraction that's undefined that represents your slope here, what you can conclude is that your line has no slope. Now what does that mean to be no slope? Well, what it means is if I were to plot these 2 points on my coordinate system and connect the 2 dots, I would find that when I connected the dots, I would get a vertical line. Now, a vertical line here has no slope because it's directly up and down. So we can say that all vertical lines have no slope or they're undefined. No slope or undefined. Now that we have that taken care of, let's look at one more. Keeping this in mind, we'll come back to that in a minute because I know it's a bit confusing. Let's go ahead and look at a couple more. We don't need this. Let's keep our slope. Well, I bet you know the slope formula by now, so let's go ahead and just take all this away. And we'll leave our no slope line there. And let's find the slope of the following. Let's say this time we want to connect -7, -11, and 3, -11. Again, using our slope formula, that gives us the following. M is equal to, basically think of it this way, the difference in y's over the difference in x's. So here we go. The difference in y's is going to give me -11 minus -11 over the difference in x's. Now I'm going to call this one this time my, again, x2, y2. So here I'm going to go -7 minus 3. Again, I did -11 minus -11, -7 minus 3. Now when I make this calculation, -11 minus -11, remember the signs change, -11 plus 11, that gives me 0. -7 and -3 give me -10. Now, hopefully you know enough about fractions that when you see 0 over -10, you know that's equivalent to the number 0. So what does this mean? It's telling me that the line that connects these 2 points has 0 slope. Now, if you were to graph these 2 points, you would get the following. You would get a totally flat or horizontal line. We call this 0 slope. So, just keep in mind, the vertical line has no slope, or it's called undefined. The horizontal line is 0 slope. It'd be hard to roll anything down a horizontal line here. So we say the slope has value of 0. Just keep those special cases in mind. Now that we did that, let's go ahead and let's graph a line using our knowledge of slope. So we're going to graph the following. We're going to graph y equals -2/3 x plus 5. Now, this equation is given in what's called slope-intercept form. So if we're going to graph, and you'll see just how fun and just how easy it is to graph an equation in this form. Again, we have the horizontal x-axis and the vertical y-axis. Now, y equals -2/3 x plus 5 is in a special form. First of all, let's find out where the y-intercept is. To find out the y-intercept, remember we have to do is let x equal 0. So if I let x equal 0 and substitute it into the equation here, -2/3 times 0 is 0, y is equal to 5. So that tells me my y-intercept is 5, or along my y-axis, 1, 2, 3, 4, 5, I know my graph is going to cross right there at y equals 5. Now, you say to yourself, you always need 2 points to graph a line. Absolutely correct. How can we use this equation to find one more point? Well, it turns out when our equations are in this form exactly, this is called slope-intercept form. This is y equals, this in front of the x, or the coefficient of the x, is our m value. This is y equals mx plus b. So, and we told you just a moment ago that b is the y-intercept. So in this case, that's 5. So it's really easy to graph these. So slope, just by examining the equation, is simply -2/3. Now, what does that mean to be a slope of -2/3? Well, remember that we said this is the difference in the y's over the difference in the x's. Or another way to look at it is we call slope the rise over the run. Now when you rise, you're moving either up or down. When you're running, you're moving either to the left or to the right. So knowing the slope of a line is going to help us to graph the line. Here we go. Slope negative 2/3. What we're going to do is start here at our y-intercept of 0, 5. Since our slope is negative 2/3, what that means is slope, rise, negative 2. Since the rise is negative 2, from the y-intercept, we're going to go down 2 points. 1, 2. So now we're here at y equals 3. The run, on the other hand, is positive 3. When we go positive 3, what that means is we run in the direction that y is positive. That means to the right. 1, 2, 3. Let me do that one more time because I know it's a bit confusing. Again, because we know the slope is negative 2/3, we're going to start at the y-intercept of 5, which we got from our equation. From our y-intercept of 5, we go down to 1, 2, and that's because the rise is negative. And then we run to the right 3 points, and that's how we get our second point. So now we're going to connect those 2 points with a straight edge. And what this tells me is that this here, this diagonal line, is the graph of the equation y equals negative 2/3 x plus 5. Now, if you're not feeling that sure of yourself, another way to check is to go ahead and calculate a couple of ordered pairs that make this equation true. Remember, we tried that method in the first or second section. So if you're not comfortable with this method yet, go ahead and plot a couple points. But if you notice one thing nice about this this form or this procedure is, again, y equals mx plus b, b representing the y-intercept of 5, using the slope to calculate my other point. And this is where some students make a mistake, so let me just mention this. We don't want to start here and use my slope. We're going to start at the y-intercept and then go down and over 3, not from the origin. Some students get confused there. So again, from the y-intercept down to over 3, plot the points, connect, and we have the graph of our equation.